Hi to everyone. We are going to conduct the experiment, that is acidity test for the water sample. The learning objective is to know the acidity concept, methodology, and the what is the values. So the aim of the experiment is to determine the methyl orange acidity, phenolphthalein acidity, or total acidity of the soil water sample. Chemicals and the accessories required: conical flask, beaker, burette, then pipette. Now, it is 0.02 normal sodium hydroxide solution, then phenolphthalein indicator, methyl orange indicator, zero point 0.1 normal sodium thiosulfide, and CO2 free or carbonate free or the distilled water. What is the theory behind this? Acidity is of a water is a quantitative capacity to neutralize the strong base. It is designated by pH, or acidity of the water is significant for water supply schemes or systems because acidity influences chemical and biological process. Why the acidity will be there? That is due to hydrogen ions present in the water. Because of that, dissociation of hydrolysis of the solution is neutralized by titration with standard strong base in the presence of indicator. Dissolved carbon dioxide generally influence the acidity. Right? So that carbon dioxide influences the acidity, and it is because that causes HCO, carbon dioxide, and OH. Right. So HCl, H2SO4, HNO3 acids are strong acids which we have in a laboratory. So hydroxyl ions is very important. So it is once again expressed in terms of CaCO3 of the hydroxyl ions, which is neutralized, right? So the pH value will be ranging from 0 to 14. If acidity is higher, then it will be maximum acidity is at from 0 to 4.2. For the mineral acids which such as HCl, H2SO4, HNO3, then it will be H2 4.2 to 8.2 for the acidity due to carbon dioxide. That will be around 8.2 to 14, right? Then there will be no major acidity when it is 8.2 to 14. So what we can say, 0 to 4.2 strong mineral acids, then 8.2 to between 8.2 and 4.2 it is carbon dioxide, and if it is more than 8.2 then there is no acidity. So major industries which are discharging the effluents such as electroplating industries, fertilizer industries, distilleries. Mineral acidity is due to the presence of HCl, H2SO4 and HNO3 acids, which are strong organic acids like acetic acid and fumic acids, which will be discharged by the industries, right? Then we have the acidity is expressed in terms of once again CaCO3 equivalent, right? So the acids which are very corrosive in nature, right? So if the acidity is high, then the pH value will be, generally we know that pH value is 0 to 14. So the 0 to 4.2 is the pH value. Then it is mineral acids. We know mineral acids HCl, H2SO4, HNO3s. Then 4.2 to 8.2 it is carbon dioxide, or we can say carbonic acids. 8.2 to 14 there is no acidity as such. So what are the causes of acidity? One thing is discharge of effluent from the different industries such as electroplating industries, fertilizer industries, distilleries, etc., mining industries. So there is no limit for drinking water, but as per Indian standards, acidity should be less for the drinking, right? If the acidity is very high, more than 50 mg per liter, then water will cause corrosive nature, or very much corrosive. When we use the water for the RCC work, then the steels may get corroded. Next we will see the experiment. Namaste to everyone. Now we are going to conduct the acidity test. So for the acidity test, we require conical flask, then burette, then 25 ml pipette, then we require funnel. So these are the almost accessories are required. Then for the titration and the chemical analysis, we require 0.02 normal sodium hydroxide, that is NaOH, that I have to fill it in the burette. Then 25 ml of sample I have to take. Then we require 1.1 normal sodium thiosulfide. Then we require two chemicals, one indicators. First one is methyl orange, then phenolphthalein. So first I will take 25 ml of sample into conical flask. Then I will add 2 drops or 3 drops of sodium thiosulfide, that is to remove whatever the residual chlorine present in the sample. So I will filter it, stir it. Then for the one beaker, I will add methyl orange indicator. For the other one, I will add phenolphthalein indicator. So we have to add 2 drops. So when I had methyl orange indicator, you can see the faint red color or the little bit orangish color what is there in the beaker. So first I will titrate this with the sodium hydroxide. So I have to take the initial reading. Now it is 0. So you can see the color here. It matches with this color. Very slowly I have to titrate it. Now the color becomes little bit orange or the yellowish color. So we can see match. We can match this. So initially the color was pink or little bit red. Then it will come to light orange or the yellowish. So note down the reading. Now it is 2.3, 0 to 2.3. Initial reading I have to take 0 and final reading I have taken 2.3. Now this is the methyl orange acidity, right? Next, for this I have added the methyl orange already added, sorry, phenolphthalein indicator. Now once again I have to titrate it. So initial reading was 2.3. Now we have to titrate until it becomes pink color. Very slowly I have to add. So now already it comes to pink. So colorless to pink. My initial reading was 2.3. Now it is 6.5. So initial reading is 2.3 and final reading is 6.5. 6.5 minus 2.3, that is the final reading, right? So that is the experiment what we can do for the acidity test. Thank you. Next we will go for the calculations. In the calculations we have methyl orange acidity calculation, phenolphthalein acidity calculations, right? So first V1, I will go for the consumed sodium hydroxide, that is V1, that is how much consumption consumed for the methyl orange addition. Initial reading and final reading is there. So V1 is equal to final reading minus initial reading. N is the normality, that is 0.02 normal solution I have taken. 50 is the equivalent weight. ml of the sample I have taken 25 ml of sample. I can take more also or I can take less also. Right. So note down what is the value of methyl orange acidity. Similarly, what is the value for V2? Say for example it is 0, 5.2 minus 0 is 5.2. Right, here it will be the initial reading is 5.2, say it is 10.5, then 10.5 minus 5.2, that is 5.3, that is V2 here, and N is once again 0.02, 50, 1000 and 25. Note down what is the value of V2. Afterwards, next. This is the tabular column. Once again, initial reading. Here I have to go for final reading, initial reading, and the value. 3 trials I have to take, minimum 3 trials. Average I have to take for V1. Similarly for the phenolphthalein, minimum 3 trials. Note down the average. Then you substitute in the formulas, you will get the values. Whatever the value you have taken, finally you have to note down in the result.